Okay, so I'm picking up exactly where I left off in the previous video. We're going to continue talking about global illumination because it's a pretty big topic and there's plenty to cover. Okay, so we saw that the radius is a pretty good parameter, but the problem is that when we lower the parameter, we increase the accuracy of the lighting, but we end up needing more photons to fill in these gaps. So how do we do that? Well, what we have to do is basically come over here to the light itself, and in the global illumination properties over here, we have to increase the amount of photons. So let's go ahead and do that. Let's go from 1,000 to 100,000. And there we go. Now we can see that a lot of that nasty artifacting went away. Since we have so many more photons now, we can dedicate a lot more photons to our scene. Now it still looks kind of splotchy and spotty, which is not good. It's not supposed to look that way. Okay? Now, once we start to introduce more photons, we can start to increase this accuracy and fix this blotchiness up a little bit. But again, the accuracy is going to reach a point where it's basically going to go, well, there just aren't enough photons for me to increase the quality of the render. So let's go ahead and increase this. And you notice that it's really not increasing the quality of the render too much. That's because we're going to need a lot more photons. Okay? So let's go ahead and let's do that. Let's go back to the light. And let's increase the amount of photons to about, say, I don't know, about 1 million. That's a 1 and 6 zeros. Okay, so it took a little bit longer to render. You saw that it kind of stopped, kind of had a little hiccup there, simply because we have so many more photons. You also notice that we have still a lot of blotching in our scene. So let's go back and try to increase that accuracy a little bit more. So let's go to 1,000. Taking a little moment there. There we go. Did you see that? Let me go ahead and show you that again. And what I'm going to do is I'm going to save this render here by clicking the Keep Image. I'm going to go back to an accuracy of 500. And I'm going to go ahead and just let it do its thing. There it is. Okay. So here's the before. This is with an accuracy of 1,000. And here's the after, an accuracy of only 500. You see the major difference? When we were using a number of photons that was too few, it wouldn't make a difference at all. But now that we have 1 million photons for the accuracy to play around with, now when we increase the accuracy, you'll notice that the effect looks better. So here it is with an accuracy of 500, and here it is with an accuracy of 1,000. So it automatically looks a whole lot better. I'll remove that image. I'm going to go back to an accuracy of 1,000 because it just looks so much better. Okay. Now 1 million photons is still not enough for the scene. We have to add more photons to the scene. So let's go ahead and add more than 1 million. Let's add 2 million. So let's go 2 and 6 zeros. Okay. And it's going to take a little moment there to update in the IPR. We have twice as many photons now. Now you can see we have a little bit of blotchiness there. So let's go back to the accuracy here and let's increase it to 2,000. And it's just going to kind of hang there for a little moment while it calculates the new photon emission there. And there we go. It cleared up a lot of that blotchiness and stuff like that. Okay. Now you notice that we still have a little bit of blotchiness. It's very subtle, but it is there, especially on the ceiling. How can we get rid of that? Well, that's when this radius parameter here comes into play. Okay. Now, if we set the radius down to 0, which basically tells mental ray, you know what? You decide what the best radius for this specific scene is. And it's going to go ahead and do that. There it is. Some of the blotchiness went away, but we still have some blotchiness in there. Alright, so what can we do to get rid of some of that extra little bit of subtle blotchiness that's on the ceiling and on the walls and stuff? What can we do? Well, we can increase the radius. Now, we've used a radius of 2, which was too small, as we saw before. So maybe we can increase it to something like, say, 5. Let's let it go ahead and update there. It's just going to take a little moment. It is 2 million photons. There it is. And that didn't make too much of a difference, so let's increase the radius to about 10. That should make a pretty big difference, I'm hoping. Here we go. Come on. There it goes. And very little difference there. So what I'm going to do is I'm going to increase the accuracy here. I'm going to increase it to about 4,000. And increasing the accuracy really doesn't increase rendering time by too much, to be honest with you. Okay, it got rid of most of the splotchiness up there in the ceiling, and this is looking pretty good. Okay, if we wanted to improve the look of this, we would add more photons. Right now we're using 2 million photons for this room. And believe it or not, as hard as it may seem to believe, as hard as it is to believe this, you actually need more than 2 million photons to make a scene, even a simple scene like this, look really good with global illumination. Okay, now next thing I'm going to show you is, let's go back to the render settings. For global illumination, we have a few different tabs here. We have the caustics parameters, which we're not going to go ahead and deal with right now. We'll deal with that later once we get to that chapter. We have Photon Tracing. Now, Photon Tracing controls the amount of times that photons can reflect and refract, and the maximum of times of those combinations of reflections and refractions in your scene. Okay, so that's very important. If this number is set too low, photons won't be able to properly reflect and refract in your scene. The default settings are 5, 5, and 5. I don't like those default settings. I would actually change those settings. The max depth, I would change to 10. That way there can be 5 reflections and 5 refractions, as opposed to limiting it to only pretty much a combination of 5 between the two, which wouldn't be too good. I wouldn't like that too much. Okay? Now, let me go over here to the Photon Map here. The Photon Map settings are really, really important. Okay? Let's go ahead and go over this stuff here real quick. Now, the Photon Map file right now is an empty field. What's a Photon Map file? Well, what mental ray does when it calculates the photons in the scene, it can actually save them out to an actual map file that's saved to your hard drive. By default, it's saved to a directory inside of your project folder for Maya. The project folder in this case being the tutorial project folder that came with this tutorial that we loaded up in the very first video of this training product. So we can actually go ahead and type in a file name. The file name could be anything that you want. So for example, let's call this room, and we can leave it just as room. We can also give it an extension. You don't have to give it an extension, but I like to give it an extension just so I know what this file is later if I'm looking through my folders in Windows or whatever I'm using. Okay, so I'll call it room.phmap, which is short for Photon Map. Okay, and now what's going to happen is it's going to go ahead and update. Actually, I'll just force it to do a regular render. So it's going to do regular render. And when you do regular renders, down here, you can actually see the photon emission right here, the progress, in the lower left part of the interface. Okay, so there it is. Render time was about 13 seconds. Not bad for 2 million photons. Yep, 2 million photons. Okay, now next thing I'm going to do is I'm going to go into Windows here, and I'm going to go ahead and look at my project directory. Okay, so here's my project directory, i3 Tutorials Intro Mental Ray. If I go ahead and double click on it to open it up, these are the default folders. This is basically the directory structure that Maya creates when you create a new project, which I did when I created the project directory for this tutorial. Okay, so we have folders for putting away our scenes, our source images for textures, and then we have rendered data. Let's go ahead and open up the rendered data folder, and we'll find ourselves 4 folders. A folder to put away depth, mental ray, shaders, and IPR images. Let's go to mental ray. And in mental ray, we'll find ourselves 4 more folders. We'll find ourselves folders for our final gather maps, light maps, photon maps, and shadow maps. Right now we're working with global illumination, which means we're working with photon maps. So let's open that up. And there we go. We can see that we have a map here called room.phmap. That's the map that I just created. As you can see over here in Maya, there it is, room.phmap. And the size of the file, as you can see, is 40 megabytes with 2 million photons. That's a pretty big photon map. 2 million photons comes out to about 40 megabytes. So there you go. So when we create these photon map files, they're actually saved to the disk, which is very important because they can be reused later. How can they be reused? Well, see how we have this option here for rebuild photon map? It's on by default. That means that every time you render the scene out, global illumination will be calculated with the lights in the scene. If I turn that off and then I render again, notice how much faster we render now. We skipped the entire global illumination process. Notice the render time went from 13 seconds to only 5 seconds down here. The reason that happened, of course, is because we turned rebuild off. So why do we have the photons here in our scene even though we turned rebuild off? Well, the reason is because it's reading this photon map. It saved the global illumination data to that pH map, to that photon map, which is a 40 megabyte size file. And it basically reloads that photon map file when you render this image out, when you have rebuild photon map turned off. And the great thing about this is, because the photons are shot in our scene, we can turn the camera around and look at the scene from different angles, and the global illumination actually worked for the entire scene. So we can see that there is some global illumination in these back walls over here, which looks really, really cool. If I render that out, you can see that back corner of the room. Awesome. So global illumination is for basically for the entire room. Okay, let me just try to find my camera angle back here. Render that again. Okay, so that's how that photon map works. Let's go ahead and turn on rebuild again. And down here we have this enable map visualizer button. Let's turn that on. Okay, and let's render again. And it's going to go ahead and render. It's going to do its thing. Pretty simple, pretty straightforward. It's going to do something a little bit different this time. The map visualizer is a 3D representation of the photons in your scene. Let's go ahead and close the render view here. Let's close the render settings. And let's close the attribute editor for this light. And wow, what is this? This is not a bug. What you're seeing right now, all these little white dots everywhere, it's not a bug, it's not an artifact in the viewport. Maya didn't break, don't worry. It's actually perfectly normal. Let's go to wireframe view, and now the dots turn red. What are all these dots in our scene? What's going on here? Well, these dots represent global illumination photons. The more global illumination photons you use, in this case 2 million, the more dots you're going to have. So there's literally about 2 million little global illumination dots all over our scene. And these dots represent the actual 3D position of where our photons landed. So this is a great tool. The map visualizer is a fantastic tool for visualizing the photons in your scene in your 3D viewport, which makes it perfect for seeing what areas are getting photons, what areas might be missing photons, and things like that. It's a great visual tool for diagnosing and basically tweaking and working with global illumination photons in mental ray from Maya. Now, one key thing is you can't select those little photons in your scene. So let's say you want to get rid of these little photons because they do slow down the speed at which you can interact with your viewport here. So how do you get rid of this map visualizer? Well, that's pretty easy. If we come up here to the render menu, let's go down to editor, edit that out of the video, made a mistake. Starting again in 3, 2, 1. So how can we get rid of these little dots in your scene? Well, it's pretty easy. If we come over here to Window, go to Rendering Editors, we can go down here to Mental Ray, and then down here we can go to Map Visualizer. When we open that up, we get this Mental Ray Map Visualizer window. And here is the map file name of our Photon Map, which, as you remember, we called it room.photonmap. We have the visibility set on for global illumination photons, which we can turn on or off. We can also set visibility for caustic or volume photons. We're not using either of those, so it's not going to make a difference, as you can see. We can change the size of the dots in the viewport, so we can make them bigger or smaller. It's preferable to keep them at the default size, however. And we have a few other options and parameters here that we can tweak as well. Okay, if you're done with the map visualizer and you don't want to see these dots anymore, you can do a couple of things. You can turn it off temporarily and then turn it back on. Or you can delete this map visualizer node altogether. Simply hit delete down here and there you go. Now it's gone, and once after you use it, you're done with it, don't need it anymore. You can simply delete it, get rid of it, and you're back to square one. Okay, before I wrap up this video, I want to show you one more way to diagnose and work with your photons here, similar to the map visualizer, but without a 3D representation. Let me show you what I'm talking about here, if that doesn't make any sense. Let me go ahead and render that out again. Actually, let me stop it. If you want to cancel out a render, just hit the escape key on the keyboard and the render will be canceled out. As you can see, there's the map visualizer. Let me go to my render settings. I'm going to turn enable map visualizer off. Let me go back to my map visualizer settings over here and let me delete that. Okay, I turned map visualizer off. Now down here you'll see this diagnose photon option here. It's turned off by default. Before I do anything, let me select this area light, hit Control A to open up the attribute editor, and let me lower the amount of global illumination photons. That way it just renders much faster. So let me drop it to about 200,000, which will render out very fast, as opposed to 2 million. Okay, what I'm going to do is render this out. There we go. Okay, it's rebuilding a photon map. Fantastic. What I'm going to do is I'm going to turn diagnose photon on. So there's two options for on. We can show the density or the irradiance. Let's show the density. Let's render again. Here's one important keynote you want to keep aware of. Do not use IPR when you're using these diagnostic modes like density and irradiance. The reason you shouldn't do that is because IPR doesn't work well with that and it will crash Maya most of the time. So be aware of that. Don't use IPR with these diagnostic photon modes. Okay. Now everything just looks blue. Let's go ahead and increase this photon density to about 1. I'm just going to do some render regions here. And there we go. Now we can see something else pretty interesting. This diagnostic mode, what basically it allows you to do, let's increase the density to about 5. Do another render region. Again, we can't use the IPR with this because it'll crash Maya. As we change the photon density, the color representations are changed here in this diagnostic render. What this diagnostic render allows us to do, it allows us to go ahead and get a visual representation in a render view of the density as well as the irradiance of our photons. So let's switch to irradiance here, do render region. And now we can see the irradiance of the photons. Basically, the areas that are greener or brighter are areas that are getting more irradiance. Areas that are softer or cooler, more toward blue, are areas that are getting less irradiance. So what this can do, it can help you to visualize in the render view which areas are getting more irradiance than others. And if we change the photon density, it basically changes the scale of the map. I'm going to stick with 5 because 5 looks pretty good. Okay, so if I take the radius of my photons here, drop it to about 2, do another render, I'm going to get a splotchy effect here. And again, this allows me to see using this blue scale image. It allows me to see which areas have more radiance than others. If I go to density, do another render with a radius of 2, we can see the areas that are dense and the areas that are not dense. So it's a very useful parameter. So you can use this to see which areas, just basically seeing your scene, density and irradiance in a visual representation. I'm going to go ahead and turn that off. And let's render again. Okay. Alright, so let's do our final render for this scene. I'm going to go ahead and increase the radius again back up to about 10 is what it was. And I'll leave the rebuild photon map turned on. One other thing, keep in mind, notice that the photon map got smaller. It went from 40 megabytes to 4 megabytes. The reason for that is because we reduced the amount of photons. So let's go ahead and close this. Let's open up the attribute editor for our area light. Remember, we reduced the amount of global illumination photons from 2 million to only 200,000. That reduced the size of the photon map from 40 megabytes to only 4 megabytes. So let's increase it to 2 million again. Close that. And everything else looks good. We'll just go ahead and do a render here. And there we go. Now we can turn rebuild off and we can just render and render and render over and over again without having to rebuild the Photon map. So this is great. Okay, so that'll get you up and running with Photons. We went over a lot of these settings in pretty good detail, spent a good amount of time on it, and we're going to finish up here. In the next video, things are going to get very, very interesting. You'll see what I mean. So I'll see you in the next video.